Okay guys, next we are going to talk about double integrals on non-rectangular region, bounded region. Okay, so you suppose that we have a function like f of xy which is continuous on a bounded region R. So listen very carefully. Depending on how the region R is described or bounded, we consider three cases separately. You can see starting with the first case. Let me show you some figure. Okay, this is the first case. Look at the bounded region R here. So here we have a lower curve y equals g1 of x, and we have another curve, upper curve y equals g2 of x, and two vertical line x equals a, x equals b. Look at here. You suppose that you are walking inside this region R. Do you agree with me? We can describe the region R like this, region R like this. We can say x is from A to B, right? X is from A to B, and y from the lower curve, it means g1 of x, to upper curve, which means g2 of x. So if the region R is described like this, the integral of fxy on R equals, look at here, the integral of f dy dx. It means first with respect to y, then with respect to x. And you can see here, here we have g1 of x, the lower limit, and g2 of x, the upper limit for y, and then x is from A to B. So we set up the integral like this. This is the correct way to set up the integral when R is described like this. Now, similarly, we are going to integrate first with respect to y. So it means we view y as a variable, everything other than y as a constant. So once we calculate this integral, the first one with respect to y, whatever is left is a function of x. Then the second time we integrate with respect to x, then we can find the answer. Regarding this first case, let's check some example here. Here you can see the explanation for case 1. So let's move on to page 16. Okay, look at here. We want to calculate the volume of the prism with top surface z equals 3 minus x minus y, okay, which is actually plane here, with this triangular base. So this is our solid. We want to calculate the volume. So you can see the base is this triangle, and here the top surface is this a portion of this plane. So actually the volume of this prism equals the double integral of this function on this region R, triangular region. And you can see this function on region R is positive because the surface of the function is located above xy plane. So we have to calculate to find the volume. We have to calculate the double function, the double integral of this function on this region R. So we have to describe the region R, then set up the integral, and then solve it. Look at this is our base or region R here. So do you agree with me? To describe this triangular region R, I can say x is from 0 to 1, right? And y is from this lower curve. What is this lower curve? Y equals 0, right? This is y equals 0. So y is from 0 to upper curve. What is this upper curve? It's this line, y equals x. So you can see here, the integral of z equals f of xy 3 minus x minus y dy dx. y is from 0 to x, we can see here, and x is from 0 to 1. Okay, now the integral is set up correctly. Let's solve it. So the first integral with respect to y, right? You can see here from 0 to x, okay, with respect to y. So integral of 3y with respect to y, minus the integral of x is a constant. So integral of minus x with respect to y is minus xy. Minus the integral of y with respect to y is y squared divided by 2. Now the value of this term when y equals x minus when y equals 0. So when y equals x, so we have, you can see here, 3x minus x times x squared minus y is x squared divided by 2. And when x is 0, so sorry, when y is 0. Now when y is 0, so this one is 0, x times 0, 0, and y here 0, so this term completes 0. So only left 3x minus 3x squared divided by 2. So next we are going to calculate the integral of this term with respect to x from 0 to 1. So you can see the integral of 3x is 3x squared divided by 2 minus 3/2 times the integral of okay, look at here, we can say minus 1/2 times the integral of 3x squared. The integral of 3x squared is x3 divided by 2 from 0 to 1. So when x is 1 is, you can see here, 3/2 minus 1/2. When x is 0, this is completely 0. So left 3/2 minus 1/2 equals 1. So this is the volume. So remember, we are calculating the volume. The answer cannot be negative.